couldn't find the original presentation. This is kind of a pre-writing of it, but you'll get the gist out of the material. Let me just take another quick look. Kind of an ad hoc. This presentation was at DEF CON 13, and I did it here about 3 or 4 weeks ago at Interzone. We have a couple pieces of code associated to this. The initial piece of, it's really simple code, and you'll see in the presentation, was released at DEF CON for the users to go ahead and do with. And there was another piece of code basically called Impersonate, which you'll see demonstrated here. That was released at Interzone. We didn't release it at DEF CON. There was a little bit of uneasiness about doing that because of what possibility piece of code, but we finally gave up on that and went ahead and released it. I had such a backlash on people wanting it. Then they realized how simple and small it was. They were like, oh geez. Okay, today's presentation, the Insecure Workstation. The information provided in this presentation is for educational purposes only. I am no way responsible for any damage that is a result of the use or misuse provided in this presentation. There were originally 2 parts to this presentation. We're only going to do one. We're doing subverting Windows logon. The key takeaways is better understanding of desktop console vulnerabilities, protecting information assets with layered defense principles, and everything. You get some people laughing there. You typically see people say defense in-depth principles. Well, what I'm trying to do is get everyone to throw that term out and start using layered defense, because I own the site layereddefense.com, and I figure push come to shove, I can at least sell the site for a couple grand down the road. And subverting desktop security for fun and entertainment. Let's skip over to help APIs. And this was a project we were working on. Basically, hey, you get a Windows logon prompt that comes up. Is there any ways for an attacker to subvert that? Whether he does it up front or whether he backdoors it, can it be done? So that's some of the stuff we were looking into doing. Credit for all the hard work. I didn't do all this myself. I had a couple friends who helped me out building this project and doing a little bit of the research involved in it. 3 rules that drove this research. I like things that are extremely simple. I don't like complex attacks and hacks. It needs to fit into my pocket, if not my head. It's something you have to be able to carry in simply on a USB stick or on a small CD. That's the type of attack I like. And you must be able to protect against it. I want the people that I'm showing this stuff to can go back to their organization and go, hey, look at this. Wow. What are we doing to protect against this type of stuff? And have some simple things that they can do to actually reduce the risk within their environment. Why, what, why, where, when, how. Basically, can Windows logon be subverted? Yes, and it's really now, why do we do this? Was it curiosity just because it's there? No, we're actually trying to create a learning experience that people can take back and actually better secure their environments when they have a true understanding of the risk and threats that are involved in some desktop security. Things that can be done. It works against XP, Windows 2003. Bob is back on the job. What that basically means is in a presentation I did at DEF CON 12, I introduced this hacker character, Bob, who basically would subvert security within his organization. Well, Bob's going to get kind of promoted in the story here, so you'll get to see that. How this attack takes place, well, there's 2 main pieces of it. There's a methodology, the attack process. So basically, we've taken some simple programmatic programs, in themselves mean nothing, built a methodology around this to deploy these, to handle these, and put them in the right place, that we could subvert Windows logon and do some other nasty things. So we're going to start out. Exploit part 1, Utility Manager. I don't know if everyone's familiar with Utility Manager. What is a Utility Manager? Utility Manager is an application that Microsoft's put on here that gives you access to things like the on-screen keyboard, to give you the magnifier, and the audio part that reads the text stuff that you click on. It's usually tools that have been put on here for people that have certain handicaps. Okay, let's take a look. I want to take a look at what Microsoft says about their Utility Manager. Basically, Utility Manager enables users to check an accessibility program status, start and stop accessibility programs. So basically, it's an application that you use to start and stop other applications. Simple as that. So where it starts breaking down, Microsoft's nice enough to tell us that, users can also start accessibility programs before logging onto the computer by pressing the Windows logo key and the U on the welcome screen. So basically, Windows has given us an application that we can use to start and stop other applications prior to ever logging onto the box. So why is this such a problem? Well, when you log onto the box and you start Windows Utility Manager up, it starts running under your credentials. But if you're not logged onto the box and you do it, it runs under System. So Microsoft's given us an application that we can start and stop other applications on the box at system level without ever logging on. So I think you're starting to see how the security's breaking down here real quick. The exploit part 2, the log on screen. To get into this architecture and how we could get this to work, let's step back here real quick. Why is this such a problem? I mentioned that you can do the system level stuff. So basically, we were starting to think about this at this point, and we thought, okay, well, osk.exe is the on-screen keyboard. What if we replaced it with just Command-exe? Just go ahead, rename cmd.exe, osk.exe, and drop it in there, what would happen? So we did that. Windows U, and clicked on the osk.exe, the on-screen keyboard, and it looked like nothing happened. But we looked into the system and we found out Command-exe did execute and was running on the system at system level. We did not get any security errors or anything kicked back from Microsoft. The problem was it was running in a non-interactive mode. It was actually running like a service in the background. So that brings us to the next part. Why was it doing that, and how do we fix that problem? User interface objects are managed using Windows stations and desktops. Basically, Windows stations come in 2 flavors, interactive and non-interactive Windows station. And in a program, to define an interactive station, something that the user can interface with on a desktop, you have to define it with an application to run under Windows 0. That is the only active functionality. Second, Windows has multiple desktop environments. When you're on your box, you've logged in and you're working in what's known as the default desktop. That means if an application kicks off a process, it can be defined as Windows 0 default desktop. That means run this interactively on the user's default desktop. Screensaver is another desktop. We haven't really done anything with that, but the log on is a separate desktop. So basically what we need to do now is we need to define the process that we want to run on the WinLogon desktop. We define it to run under Windows 0 desktop WinLogon. And if we do that, our process should run within that environment without us ever logging on. So that came to the third part. Okay, now we need to build the code for that. The code in itself poses no issues. Basically, we're just setting a create process thread to run under the WinLogon desktop using Windows 0, the interactive desktop. The security breakdown is how we're using it, the methodology. We are taking advantage of architectural design issue within Microsoft, and that design issue is the fact that Microsoft gave the users the ability to start and stop applications at system level without ever logging on. And the code is extremely simple. It's the code. As you can see in the code, basically we're defining the desktop as Windows 0 WinLogon, and then we're running the process Command-exe. So basically, if we take this program, compile it up, replace the osk.exe on the system, we can come to a box, go WinU, bring it up, go osk, and get a command prompt on the box without ever logging on. So come to the final part of this. How do we get the code on the box, the delivery method? Now, we looked at several different methods. If you have admin access, you can replace the OSK. There's ways of doing it. Hey, you're already admin access. Who really cares at this point? API vulnerabilities, you can use existing. That was in the first part of the presentation that I'd done out there. You can use API call vulnerabilities where you can escalate your rights to system level. And at that point, you can go ahead and change the files. But you're on system level, so there's nothing to gain there. One of the hardest things we worked on and got it to work was bit level modification of the hard disk. We actually booted up on a DOS, I can't remember what DOS version it was, identified the tracks and sectors that OSK was written on, and then overwrote the first 512 bytes with our code and got that to work. But it's extremely complex. The easiest thing to do is a maintenance boot disk, Windows PE or a BART PE disk, simple enough. So what I did was I took a BART PE disk, set it up, modified everything on it, so you walk in there, you slap that into the CD-ROM, boot off of it. When it boots up and done booting, you pull the disk off, shut the power off, walk away. At that point, it should replace the OSK. No interaction from the user other than just mounting up the CD or booting from the CD. And that seemed to be the best way to do it. Very simple, easily available to everyone on the internet. Okay, so now let's look at this whole vulnerability. So instead of me logging out, we'll go ahead and the story I put together for this whole thing is kind of interesting. What if you had a company in the research development department and they were coming up with all these new secrets and they had a competitor down the road. That competitor decided, hey, you know what? We can make a really good money if we can steal the stuff that he's working on because he's getting ready to go to market. So how do we do that? Well, you know, let's go ahead and get one of our people to work for his janitorial services. Okay, so what they do is they talk Bob, one of their employees, into going down there and applying for a job as a janitor. Of course, Bob gets hired. Okay, so the first night on the job, Bob shows up with all of his tools, his USBs, CDs. He goes around the different offices. He walks up to the office. Let's say he walks up to John's office. He slaps, John happens to be the manager of the research and development team. He slaps the CD in there, boots off the box, shuts it off, walks out, goes and does his job, does his cleaning. John comes in the next day, logs on to this machine, does his work throughout the day, and when John's done, what's John do? He either walks away from his box and the screensaver locks the box, or he locks it himself. So here we are. John's walked out, he's gone out of the office for the day. In comes Bob. Bob walks up to this machine. He knows what he's done. Windows U key. He brings up the utility manager. On-screen keyboard is running. Starts it up. Boom. He has a command prompt without ever logging into the machine. Now from here, there's a lot of things Bob can do. He can copy files. He can use some methods we use for stealing stuff off the system. He can use some password tools for dumping the hashes, taking them offline and cracking them. Some of the other things he can do that we've actually tested is using like Tiny Hexer, a memory program. Since we're running at system level here, scan down through all the running processes, scan for the words password, passwd, pwd. And we've been successful in quite a few cases of stripping passwords right out of running processes on a box. It's quite common. I know we can pull them out for if you're running Novell. We know the offsets that you can strip the passwords out for a Novell connection. Most of IBM's workplace type stuff is Java driven, is riddled with the password. It's not in there once, it's like in there a dozen times. So there's a lot of ways to strip stuff off that way. One thing we did find out in this environment, you can get up a full desktop, but it's resource intensive and it'll start flaking out and the graphics will start breaking down after a period of time. You're better off running individual apps that you may want to run from here. Unfortunately, I don't have a separate drive to do network connections and stuff because there's some other stuff I want to show you. you can at least talk those points, and I think you'll get the gist from that. So as you can see, Bob's on the system with this command DXE running at system level. I'm still logged onto the system here. One of the biggest things is when you get into a system like this and you run it at system level, the problem is I don't have access to the person's logged in network drives. So if the logged in user has a bunch of network drives, you can't get access to them at system level. You just can't do it. So we start looking into, well, how can we? How can we actually become or steal the security rights, the security cookie of the running user? So we went to Microsoft's development network, started doing some research, and we discovered, yes, we can. So we wrote a quick little program called Impersonate. The way Impersonate works, the way we have it written up, IMP, and then all is a process ID off any running process owned by the user whose rights we want to steal. So we'll grab process ID 2268. So we run Impersonate with 2268, comes back as successful. Now if we sort on here, we see we have two command DXEs. We have one running at system and one running as the user. So what we just did was we had our process go in, steal his token, or his security token off his running process. Since we're at system level, we have access to that. And then we turned around and created a process to run as that user using that security token. The weird thing is we have one window here. In that one window, we actually have two command DXEs running under two different users. And we found out if I would go ahead and type in a command right now, it would run as system. And the would still look like it's the same one, but if I type in another command, it would run as the user's token we stole. So we found out the best way to handle that is exit out of one of them. Now we are DSH. We didn't know his password. We pulled his security token off a running process, and we actually degraded our rights down to the user. Instantly, if that user had any mapped drives, we just gained access to all of his network resources. If we wanted to, we could actually map new drives as that user to any other systems that he has rights to. Just a couple quick things. Now we got that back up again. Let's go ahead and shut this down just so you can see it. We won't leave it up long, but there's a full desktop without even logging on. There's still the log on there. So now if we log back in, just so you can see the multiple desktop environment that it does exist, there's that desktop, and if we do Control-Alt-Delete, it switches us back to the other desktop. Cancel back to the other desktop. So you can see it's a multiple desktop environment. One, we've gained access but bypassing the WinLogon desktop, we've got access. Now we can also impersonate any running users that are logged onto that system by stealing their security token, grabbing access to any of their network resources. Let me shut a few of these things down. No. Come on. Desktop. Okay. Did that, we did that. Okay. Now, what kind of questions does this whole demonstration pose? Basic protection. How do you protect my system from these type of exploits? You may be able to do it with group policies, and I say maybe because if you'd seen my presentation at DEF CON 12, it was completely on Windows group policies, so those only work so well. You can remove or disable utility manager. If the user knows that's been done, the attacker knows that can be done, he can easily put that back on there with a BART PE disk, so that's not a problem. Big one, disable boot CD-ROM, lock the BIOS, disable booting from a USB devices. That actually would hurt this really quickly. It would slow him down. He'd have to find a whole new method. You can run host IDS on a server if you're trying to protect the server, because typically what this thing does, it puts two files on it. It puts the IMP within the System32 directory. It replaces the osk.exe. So typically a good host-based IDS on a server will protect you. Also, this attack works, at least the OSK part, works against remote desktop. So if you put this onto a box, you can go in with remote desktop and get a command and if you go against the server, you don't have limitations with Explorer. You can bring up the full desktop without running out any resources. So you could basically do this to a server or anything that has remote desktop, remote into this box, Windows U, get a command prompt up, launch Explorer, have a full desktop that you can do anything you want with for a certain period of time. Because you've never actually logged in with remote desktop, it will time out and show on the screen. No, they'll never know you're on there, and nothing's ever logged because you never log onto the machine. That's one of the things we notice. You know, it's like, hey, you know, typically you have a log on. You know, it shows the person logging on within the logs. You've never logged on. There's nothing in the logs. Now, if you turn on logging with enough intensity, you'd probably catch maybe applications starting and stopping if you have that capability. But it's going to be starting and stopping by system. The impersonation we have not written to work with remote desktop. There's some different issues with a remote desktop console versus a standard console. This code could easily be rewritten. The impersonation can. I think if we define in the create process as user the function to create a console, by that we're just accepting the default console, but remote desktop, if you set the create process as user and set the console to open up, a new console to be created, you'd probably get it to work. So how do you prevent backdoors by, an example, employees? I mean, you start out with policies. Obviously, you want to set policies within your environment to protect yourself. Separation of duties. And when I say separation of duties, you think about this. If you wanted to backdoor every machine in a corporation, how would he do it? I don't know. Where do you store your base images at? What if it happens to be the guy that does the base images? Do you have any checks and balances there? I mean, some organizations, they have one guy. He builds the base images. No one ever else looks at them. He builds them and they deploy them. So what if he built them and deployed osk.exe hack in there? What if he deployed some other kind of backdoor? You know, these are things you need to talk about. Separation of duties is checks and balances. You know, this person decides this is what we're going to do for a base image. This person verifies it. You have some kind of testing done to this thing prior to being deployed. And you also store those in a secure place. If you store a standard base image on the network somewhere where everyone can get access to, who's going to stop someone from replacing that with some kind of rooted code base image? Application system verification testing before deployment. Obviously, in references separation duties and the base images that you deploy in your organization. How do you prevent non-employees access? Let's think about this. Who is the maintenance man? And what do you really know about the night janitor? I mean, every place has to be cleaned. Do you ever see them cleaning during the day? No, they do it in the middle of the night when there's no one there. They have access to every room except for maybe your data center. So technically, they can own your network and you'll never know it and you can't stop them. Someone can use social engineering to gain physical access. Security awareness training. Keep people from just waltzing into your building. You know, you walk to the door, you got a big box, guy opens the door for you, you walk through. It's easy to get into most organizations. So how do you protect against things? Contractual agreements with contractors and outsourcers, whether it's janitorial or application development. We're really quick for building into our contract agreements protections for the organization for developers. Do we do that for janitors? Do we do background investigations for janitors? It's just a janitor, but the problem is we treat them just as janitors. And the fact is, we give these people access to everything on our company network if they want it. We don't do anything to stop them. ISO 17799 defines contractual agreements, and they actually mention janitorial service in those contractual agreements as part of the security part of that. So you need to consider those. So then we come to, I use that bad word, defense in depth. We come into layered defense principles, the only effective method to defend your network. If you try to defend your network based on, hey, I seen this hack at this conference, so we need to do this one specific thing, you're always going to be chasing your tail, because there's always hacks, vulnerabilities that you're never going to know about. So how do you defend yourself? And that's where you get into layered defense and defense in depth principles. It's basically a combination of people, processes, and technology applied at each layer. If one layer is compromised, your entire organization is not compromised. This is made up of policies, physical, parameter, internal network, host, application, and data layers. So let's take this instance of Bob and apply it to this right here. Okay, Bob came in. Bob gained physical access and policies. You can kind of bring those in together. If we had done a background investigation on Bob, you think we may have been found out that he was already employed or had been employed by one of our competitors doing a certain job, and now he's doing a janitor? That would put out some red flags. So if we had done that, our layered defense would have caught him at that level probably, and we would have stopped this at that layer. Okay, suppose we didn't do that and he gained access. He is a janitor, it's kind of hard to control physical access, except for maybe the data center. So we get all the way down. Okay, let's get down to the host level. If we had on the boxes set it up so that somebody walking up the box could not boot from a floppy, USB, or CD-ROM, instantly we would have stopped Bob there. That's another layer we could have caught him and stopped him. So then we get down to the data layer. This is a research and development firm. All of their key technical stuff is probably stored on the network somewhere. If Bob could get to that data by getting into this thing, impersonating John, grabbing his security token, getting his network resources, and downloading all that stuff, we failed there because we could have prevented that. If this is the corporate secrets, why don't we have two-factor authentication set up on that? Not just encryption, but two-factor authentication. Those research and development people, that's the core of that corporation. You should protect that. That is the jewels of that organization. And the way you do it is you classify that data as a secret data, corporate secret. Require encryption and two-factor authentication. Bob may have been able to get to the data. It would have been he would have never got to the data because he would require two-factor authentication, and the data would have been encrypted. So you could have caught him there. So basically, unknowing most of the threats that may exist coming at you, if you look at these 7 layers here and apply simple security methodologies around those layers, you could stop these type of attacks from internal and external. Specifically this one, you could have stopped him at policy to physical layer, the data layer. Any questions? Silence in the room. Yeah.
One way to mitigate that would be to require all users just to totally log off instead of blocking the workstations.
Yeah, that would be a good one, but how do you force it? Yeah, that's the thing. You can have policy like that, but you have to have the ability. That's the one on the one slide, and it's always a killer in any organization. You can come up with all kinds of cool policies. Well, we won't let them do this. We won't let them do that. But then it's, well, how do you enforce it? You know, if John refuses to do that every day, are you willing to fire him? If you are, then that's a good policy. You put it in there because he'll do it or he'll get fired. But yeah, that's one way. There's all these simple ways to mitigate the risk. When I first put this whole presentation again, I think I completely my box every day for about 6 months, but that eventually wore off. Because I showed it to enough people, I'm thinking, oh, these people find some way to screw me with this thing. Any other questions? Yeah?
Is the osk.exe the exploitation code?
Yes. We've taken that code, compiled it, and replaced the osk.exe. The cool thing is Microsoft's, I can't remember what it's called, but basically if you replace something in System 32, it'll automatically. The thing is, if you come in with a PE disk or a BART PE disk, it doesn't know it's been modified. If I would go in there right now and delete my code, my osk.exe, Microsoft would replace it with the original osk.exe, the good one. It doesn't know it's been modified until it's modified, and it has to be modified in that kernel's running OS for it to know it's been modified. So if you find another way to change it, it never knows it. Any other questions?
So it doesn't check the application signature or anything next time the user logs on? It
No.
just never notices?
Nope. 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 If you, like I said, if you would have, if you go, I didn't realize that. I thought it would recache the changed one into the cache area for restoring, like rechecking the signature and saying that's good and putting it over there, but it didn't. I found out that one day because I had that on, deleted it, and all at once Windows replaced it with the good one that it had in cache. Well, I have the code available. There's my email address, and I have some business cards if you want it. If you shoot me an email to dh@layereddefense.com, I'd be more than glad to send you both pieces of the code, the OSK and the impersonate. And then you can do anything you want with it. The only thing I ask is if you have any cool things to do with it, or you modify it, that you shoot a copy back to me. Tell me what you did. Thank you.